Hey, welcome back to RamZland. Today I want to show you how to decode your own secret message using sodium hydroxide. Check this out. To create your secret message, I'm using a solution of sodium hydroxide, and to decode it, I'm using phenolphthalein. To show how phenolphthalein is an indicator for anything that's in a basic solution, we'll use some pieces of potassium in water to create potassium hydroxide, and then we'll add a drop of phenolphthalein. So I'm going to begin by adding a little bit of sodium hydroxide in a solution to my Petri dish. And then I'm going to use a glass stir stick to draw my secret message on construction paper. Now I'm going to dip my glass stir stick in my sodium hydroxide solution, and I'm going to start writing my secret message. Now we'll decode that secret message once it's dried with phenolphthalein, which is an indicator for any solution that's a base. And we'll demonstrate that by adding some pieces of potassium metal into water. And that'll create a single displacement reaction of hydrogen gas and potassium hydroxide, which is a base. Then we'll add some drops of phenolphthalein and look for that change of color. Check this out. So first, let's remove a small piece of potassium metal. It's stored in mineral oil because it's reactive with water or humidity in the air. It's a soft metal. I can cut it easily with my spatula, and you can see the luster before that oxide layer is created. Look how bright and shiny it is. So we'll add this to our water, and that will release hydrogen gas, and it will create potassium hydroxide that's alkaline. Okay, now let's add that piece of potassium metal to a little bit of water. Check out what happens. Immediately that hydrogen gas starts to combust, and this starts to create potassium hydroxide in the water. Now right now it just looks kind of milky, kind of cloudy, but watch what happens when we add a little bit of phenolphthalein. I'm going to put a few drops in this graduated cylinder of just water, and you'll see that the color doesn't change. And that's because phenolphthalein is clear in the presence of water or anything that's acidic. But when you add it to anything that's alkaline, that has a pH of more than 7, look what happens. Here's our solution. Again, this has a little bit of that potassium metal that reacted with the water to make potassium hydroxide and hydrogen gas. Watch what happens when I add the phenolphthalein. Look at that. That beautiful purple color appears to indicate the presence of a base. Now let's see if that will work on our secret message. Now to make it easier to decode the message, I've added the phenolphthalein to a small spray bottle so I can just mist it over the message. All right, it's time to decode. Here we go. Look at that. Isn't that cool? It just appears out of nowhere. So the reason why it turns pink is because phenolphthalein is actually a weak acid. And when it's in the presence of sodium hydroxide, those molecules that are clear, they become ionized, and the color of those ionized molecules are pink. And that's why it changes its color. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.